What's our agenda today? Let's talk about the stuff that takes 70 or more percent of VR projects. What it is. Then we'll talk about series. Series is the building block of working with data and Deedle. And then we'll see, talk a little bit about data frames. A data frame is like if you want a table, data table or a data frame in other libraries. And a data frame is composed of series, as you can see. Then we do a little bit of visualization, not that fancy. And we'll be stressing that it's easy to do some graphs using Deedle. And then I'll talk about type providers. Type providers are kind of funny, like this situation of the chart. And what type providers do is that you give it a data source, whatever it is. It could be a text file, it could be a table, it could be a XML file, it could be a HTML page. And then it generates classes, like C# classes. That you can work with. So it gives you a very nice abstraction to extract and work with data with a number of sources. And then, well, although as very few of you have worked with R and Python, we'll talk about, hey, this is nice, but why wouldn't I keep using Python, for example? So we'll discuss that a little bit. And I'll end up talking about this FS Lab. Actually, Deedle is part of a broader initiative, which is an FS Lab for doing data science with WebShark. I'll show you a couple of examples. So let's go ahead. So, numbers vary. The people say that 70%, 80% or so of business intelligence project is data acquisition, getting data from different sources, Excel files, CSV files, relational tables, web pages, etc. Then you have to clean that data, have it comes in a way that you can extract it, that you can analyze it. And also, as you use several different sources, you have to homolog it, meaning that, for example, the data ranges here are similar to the data ranges from this other side, or probably the data types have different formats and things like that. And also merging the data without introducing errors or inconsistencies in our data. And then understanding the data. And when by understanding, right now, I don't mean like doing forecasting or finding trends in the data, but just getting this feeling that I'm not that much out of the field, you know, that the ballpark numbers and ideas are similar to what I'm seeing in the data. More than one time, because when you have that also BI, sometimes find out that the numbers just doesn't make sense. That you are not analyzing them, but before that, they are not making sense. Probably it's because in some part of the transformation and editing and things like that, information gets lost. So, what's a series? A series is just a set of observations. For example, that series says me that at the moment, or at point 0, we have a 0.16 in data or observation. At point 3, we had a 0.363, etc. Another way of seeing it is that a series is just a list of key value pairs. The keys are 0, 1, 2, 3, etc., and the values are the decimal numbers to the right. The keys could be of any type. Most of the time, there are numbers just like that. Another very usual option is dates and times. And then you have a time series. Okay? But you also can have strings, and you can actually have any other type as your series, even compose things like full objects. Or the same thing in the values, although most of the time in the value sides what we have is numbers or strings, most of the time. You can actually put there anything that you want. Also, it's interesting the fact that you can have missing values on the right column. Okay. And when we use, for example, relational databases, that means using rules somehow on the right side. In the F# world, we don't like rules, so we try not to use them. Instead of them, we are stressing this idea of missing values. Sometimes we call them optional values. Okay, we'll see more about that. And we're getting too much in the slides. Let's see this working. So, how many of you have at least seen F# before? Wow. So, that's a good thing. It's a good thing, great. I'm happy to see that F# is becoming ever so popular by the year. So that's a great thing. And probably so most of you have used .NET Core already, right? Or not? Yeah. Okay. So, well, Alpha of the room. So what I'm doing there is just creating a console project using .NET Core. And let's get there. Let's see. The first thing that we are going to do is to use or add the Deedle package from Nugget to the project. Okay. That to begin with, that's all that we need. And then once that one is restored, just use code. See. So project. One interesting thing of most data acquisition is that you tend to be very interactive, and of course, F# helps us a lot with the F# scripting files. Because, but first of all, how many of you have used FS6 files? Just a few of you. That's interesting. That's interesting. The thing with FS6 files is that it lets you put code, lines of code there, and execute them immediately in a type, so you don't have to compile your solution. Okay. Actually, what's going on is that we are using the F# compiler line by line in an incremental fashion. So it gives you a very Python-esque experience of using F#. Okay. So we need to do a reference to, let's see where it is. Just copy and paste some code. Struggling here. First of all, I'm just setting a reference to the place that Nugget downloads its packages most of the time. And I'm setting here, this reference here, all it does is that it takes this assembly and loads it in RAM. Remember, we are not compiling an executable per se, so that's why we are doing this reference. And from now on, we can use all the functions and types and code in general that we have defined in that assembly. Given that, the first way we can create a series is just like this. Execute it. And Deedle. And as you can see, we just have created a series where the key is an integer, and this series has got just 3 values there. Okay, Spanish. And if we wanted to be formatted in a nicer way, all we have to do is this small line. By the way, I'll be publishing my all this code in GitHub or somewhere so you can use it. The only thing this guy does is just to add a pretty printing function, so that if I just repeat this line again, just see it more nicely formatted. That is okay. But a better way of creating a series is like this. Let's do it again. Here we have this series with these keys and these values. And what we are doing is using this function and this nice operator. They define it in Deedle. And basically what you give is value, excuse me, key and value, key and value, key and value, so on and so forth. So that's the way you create a series. From then on, you can do more series stuff like this. Lines. That's it. There we go. Okay. What you're doing there is creating 100 random numbers and put it in on a series. Okay. So as luckily most of you already know F#, I'm not doing anything that you haven't seen before. So that's pretty much a series. From then on, you can start to do a number of interesting things. Like, for example, this series. You can start saying things like sorting them, for example, or sorting them by key. Or you can filter, you can do a number of operations over the series. Probably, as you already have used F#, you know lists, and lists have a number of these operations. The only interesting thing about the functions in series is that it understands more about the key, the values, the missing values, and things like that. So it makes it a more natural experience when you're working with your data. So that's very fast example about series. And then, what's wrong? Let's talk about data frames. A data frame is nothing more than a set of series. You start just with one series, and then you add a second, a third one, etc. So, for example, here, this data frame actually has got a number of series. The first one, this is always the key, and this is the first series with these values. And then you've got a second series there. And actually, also every row is also a series. So you can apply the same operations and use the same functions that you learn with series right here with data frames. Okay, so let's try and do a couple of things with data frames also. Sorry about the misleading data out there. See both. For example, just going to create a couple of series here. Here, right? Great. Okay. This part is not that important. Not. This part is not that important. Just create a couple of series there. Here's some series. The really important thing, the really new thing, Here we are creating our first frame. And to create a frame, what we do is to take a couple of series. To solve this problem. In this case, we are having 2 series, and we are giving it a name to each series. Basically, think it like the name of a company. Okay? So, just get the definition of it, that first series with this. Also, as you can see, using the FSX file, I can just execute the lines of code one by one. And here we are. This is our first frame. As you can see, the key is daytime. The first series is just that, the series I already had. The second series is this another one. A couple of interesting things. For this to work, we need to have a common data type as the key. The reason this working is because the first series has a daytime as a key, and the second series has also a daytime as a key. On the other hand, you don't need to have the same points, the same key values for both series. What this does is by default an outage of the 2 series. And these missing values here are happening because we do have values for this key in the second series, but we don't have it on the first key. You can, using additional parameters in the frame constructor, you can define whether you can do, if you want to do an inner join, a left join, a right join. Right? What is an outer join? Okay. So, yeah. Yes, you can. You can say that also. But if you do that, well, it's going to create the question was, can you sync the 2 series? And yes, you can do that, but in that case, you wouldn't have 2 series actually. You have just 1 series with the pairs series, okay, which is different. But yes, you can do that, and many times that's exactly what you want to do. Okay. What else? Let me show you another example with frames. Yeah. You can also do a transposition, meaning instead of let's do this and pay attention to these 4 rows here. What's going on here is that instead of having 1 row for each key value, we are going to have 1 column for each key value. Okay. So we are actually rotating the 2 series. Let's just execute it all. So it's a little bit hard to read, but what we are seeing here, probably after here, say. There we go. We are having 1 column per each date in this case. And we have just 2 rows. 1 row for all the values of the 2 series, and another row for all the values of the second series. What else can you do with series? You can also, if you got number of pairs, like here, tuples, you can create a frame from them. This is an interesting one. Let's see what happened there. Okay, there we go. You see, the keys are the first values, Monday, Tuesday, Wednesday, etc. And the values, Thomas becomes 1 series, and Adam becomes a second series.
So how it's the mandate the first column in the key are specified? How it treat the mandate?
Okay, the way frame of values works, it always takes the first value of the tuple as the key, always. That's all it does. Okay? So it's actually, the more interesting thing is how it goes generating the values. You notice here the missing values for Adam. That's because we don't have Adam values for Monday and Wednesday, for example. Okay. Again, I'm just showing you a few examples of how to do things. You can go to the Deedle site, and I'll give you the URL later, and you will find out a lot more examples and ways of doing stuff here. It's just to give you a taste of how this works. Okay. Also, given that many of you already use F#, we can define a type, then create a list, create a regular list, and we also have this function here. And in this case, where we are using records and use our list up there, and also we are creating okay. And again, we are creating a series. You can see that in this case, it's just creating an ordinal series and using as key just a number. But there are also ways in which you can give it keys or design one of the fields of the record as the key. Here. Oh yeah. Let's get a little bit more real. Most of the information we want to process comes from CSV or text files, and then you can do things like this. Read a CSV file and use it as a source for a frame. So, okay, happen here. See string no level. What did I do wrong here? To find a part of the path. Oh, what did it say? Because of the. It's just let me just find out the exact place where we are. Probably it is like something like this. Okay. Let's see if I was. Oh, it's not there. So, in order not to make you cringe mistakes, let's just see it here. So I'm executing this guy, and what we just did is just read a CSV file. The first column by default is used as the which in this case is a date. Sorry about that. The date is the key column, and then we have a number of columns: open, high, low, close, volume, that are just comma-separated values. A couple of interesting things happen here because the data frame is clever enough as to understand the type of every field, so it does understand that we are dealing with dates in the key, and we are dealing with decimal numbers on the open, high, close, etc. values. Okay. So let's go back here. Taking these other values here, and then we can start to do more interesting stuff with this. These are just data frames, like the ones I created by hand a minute ago. For example, you can take the frame and then index it. This is an important operation. Index redefines the key. you can start with a specific column as a key, and then you can decide that it's better idea to have a key, the second, the third, or any other column. And actually, what we do is we create a new data frame, with a different index. And also, as you can see, we can sort it at that new key here. So, also, we can slice and get a few columns. For example, here, we're taking this data frame, and we are saying that all we are interested in is these two columns. So this data frame that probably had like 5 or 6 series, the new data frame will just have a couple of series here. There, in this case, the open and close. Do notice that we do have, all we have here is just a list, a string list. So all the stuff you already know about the sharp, you can reuse it when, for example, selecting dynamically which columns you are interested in. Okay. This is another interesting operation. What we are doing here is adding a new column to the frame. Okay. This nice operator, what it does is adds a new column, and up to here, this is interesting. All the operations we'll be doing here, what it does, it creates new data frames. Every time a new data frame, a new data frame, a new data frame. This operation is a little bit different because all it does is it adds a new series or a new column to an already existing data frame. It's the only mutable operation we have here. Also, notice that we are doing is taking one column and another column, and many of the arithmetical operations and other functions have been redefined in Deedle so that it applies to every value on the columns. Here, we have 1,000 point here and 1,000 point here. Actually, this operation is executed 1,000 times. Also, it's clever because we can have missing values here or here, and all it does, well, most of the time, it does is just propagate the missing values. So, missing minus 100 is just missing. Let's do it. So, and of course, you can do, and this starts to see like a real data manipulation. We are taking the data frame we read from the CSV file, changing the key, then sorting by the new key, and then keeping just a couple of the columns, and then adding a third column. Pretty much what you can do with Python or with R, but in a strongly typed way, and also in an interactive way because I'm executing this all the time. Okay, great. So again, that's just a couple of examples of how you can manipulate, how you can work with data frames. And then, of course, data visualization. And to begin with, I'm not thinking about finding, trends in information and things like that, but just understanding if my data makes sense. We are visual animals, of course, and if we see things, we understand in a better way whether we are doing fine or wrong. Okay? Of course, after that, you have to use a number of statistical functions to corroborate your impressions. But first, let's go by impressions. With Deedle, you can use a number of visualization packages, of graphics packages, but the most popular ones are F-sharp charting. It's a nice one, and probably the oldest one. But the problem with it is that it's Windows only. It only works on Windows. On the other hand, you can use Xplot. Xplot, on the other hand, is browser-based, so it works in any browser, in any modern browser. We actually have two options for that. Google Charts, what they have done is to wrap the Google Charts JavaScript graphing functions with an F-sharp interface. So all you do is F-sharp functions, but beneath that, you are executing JavaScript action. And the same thing with Plotly, which is also a very popular JavaScript library. I also have to say that you can use these visualization libraries without Deedle. They are actually orthogonal to each other. Okay? But when you use them combined, you can get a couple of nice things. So let's go back to my examples. The not so nice thing about this is that you need a number of assemblies. Here they are. First of all, you need the ever popular JSON, and that's because underneath we are converting the data frames which are actually F-sharp values or .NET values if you like, and we are converting it to JSON so that the libraries can see it. Then we are using Google Charts by itself, and also we are using this last library. This library just better connects Google Charts with Deedle. Okay. This asset here is important because actually this one is the one that converts our F-sharp charts, if you want, to JavaScript charts. Okay. So we need to use those libraries. There. This. And the way you do a graph is like this, for example. All we are doing is taking from my data frame one of the columns, and then from another data frame, another column, and creating a line chart. If I execute it up to there, it indeed will create a chart, but that chart is just an F-sharp object. Then I'm using this chart show, and chart show is the one that actually brings up a browser window and show us the graph. So let's see how it goes on. Okay, we go, and in a sec we see the graph. Right? Here it goes. First time it takes a little bit because it's generating a number. There we go. This is the graph we just created with all the data points. By the way, there's several thousand data points there. So again, it's kind of similar to real life here. So remember, you can actually create line charts or bar charts or pie charts with any F-sharp list. That's just general. It so happens that we can also show columns in data frames or series if you want. Okay? So that's just a quick example of how we can do visualizations here. Then, type providers. Well, most of you have used F-sharp already, so probably who you are already familiar with type providers. So like 1/3 or 1/2 of the room. That's interesting because for all the guys and girls that are already using F# and haven't tried that provider, so really missing something. Really missing something. The idea behind the type provider is that at development time, even before real compilation, you create a type generator. You create, in our case, the type generator is this guy here, for example, word bank data. You'll see it working in a minute. And this guy understands its data source. In our case, the data source is the World Bank site, and it crawls the site and goes discovering all the tables you've got there and all the links you've got there, and it goes generating types, records, if you want, the sharp records. And so, for example, when we have a key worldbank.countries, countries actually is a type that's generated. And then, when you select Ecuador, for example, again, at that very moment, a new type is generated. And well, that's the end of the road, but Ecuador has a number of properties. For example, this property. Okay, and as you can see, as it's done at development time, you've got IntelliSense over the real data. Okay. In this case, this is a very nice example with the World Bank data. It uses a site, as I said before, but you can do the same with an CSV file, an XML file, HTML pages, data tables. So, in a way, it's a generalization of these object-relational mappers. An ORM, what it tries to do is to take a table, generates a set of classes that represents the tables, and then it lets you work just with the instances of this class, instead of having to work with the columns and rows of the table. So the same idea, but with several other data sources. Okay. So let's see a small example here about that. Here, for example. Oh, by the way, I've been using most of the time the code, but everything there you can also do it on. Visual Studio. You can see all I'm using is an FSX file. So that I can give you a couple of ideas of how this works. Let's go here. Okay. Well, here. This is the nicest stuff. We are using the CSV provider and accessing a CSV file I've got here. A few minutes ago, I used Deedle to create a data frame from the CSV file. What I'm going to do right now is a little bit different. I'm using another CSV file, but I'm creating a provider. This guy here, there, it's a type generator. It's going to generate a number of classes. And now I'm actually reading the data. And from then on, I can do interesting stuff. For example, I can say data of rows, and you can see the information that we got there. For example, data of rows. I take just the first row, for example, and in a second, this guy is going to show me. It's going to show me things like this here. See, I'm moving in all the rows that we got there and taking the year and creating a series. Let's see. There you go. And what you got here is a year and the depth of year and depth, so on and so forth. On the other hand, I'm creating another series with the GDP. Okay. These funny property names here are just the name of the columns on the CSV file. Okay. And then you can do things like putting a chart and things like that we did before. This is the other provider I just had in the slide. And once you have this guy here, you can see here that we've got countries. And we've got a number of countries, like, for example, States, for example. And we've got, remember, what we are doing right now is, as we are putting dots there, the type provider is navigating to the site, finding out the information available, and generating the properties on the fly. So it's pretty magical what it does. We want a number of indicators that we've got here. For example, this one. These are all the indicators that we have available. For example, access to electricity must be close to 100%. Okay. And close that in a sec. That's going to give you the number. Okay. Here we are creating a series with this particular indicator, for example. And then we can start to do operations on the series, like putting in half, something like that. And again, we can make graphs and things like that. You can also use the HTML provider. This is a different example. You just give it an URL. What this provider does is goes and tries to find out, it took a little bit of time, but then we have the numbers that we just executed about the GDP. Okay. Going back to my example, this guy will analyze the page and find out all the tables in the page. Okay. And for every table, we will analyze all the columns. Remember that these are HTML tables. And it will generate an HTML type for each one of those tables. Okay. So once we load data, we can do things like that, like this. Take the first table and then the presidents. That's the president's table. There's a president's table in that page. And take all the rows and take the first row, for example. Or you can navigate each column, like here. Okay. Just a couple of examples of what you can do with type providers.
Are those only in the FSX file?
No. What great question. The question was, those things exist only on FSS files, or scripting files, like we call them. No, you can use it everywhere. So I'm using an FSS file because it's easy to show you samples. But actually, you use them in executable regular files, in FS regular files, without problem.
So
just
some of the HTML files takes a little bit of time to load. Does it account for the wait time?
Yes, it does. Yes, it does. And actually, as you saw, using even the World Bank data that underneath is also navigating to the site. It takes a little time to get the data.
So that's different internet as well.
Yes.
So
yes.
you did that application in production, so you're opening your application. So it is secure enough, or
Well, remember it was just from inbound to outbound. So you don't really need to give access to the outside world to your application. So in that sense, it's secure enough. But yeah, on the other hand, you do, for this kind of stuff, you do need very good internet access.
So a lot of organizations, they restrict the internet access of those particular, if they don't want to your application go and get access, right?
Yeah.
Like HTML provider, right? You deliver your setting to get data, right?
Exactly. Yeah.
So in that case, how that application work? Is it like so stored locally, or is it gonna store exception for you, or how would that?
It's going to throw exceptions. Also, eventually, even though it accounts for waiting for the page to download, it eventually can give you timeouts. So you can get exceptions here. So in the real world, you are going to put that try catch there, for sure. Okay. Of this. Yeah, let's go ahead. So let's go back to my slides. And okay, this is interesting. This is nice, but why? Luckily, as most of you work with F#, the answer is because so I can keep using F#, even if I'm in a BI project. It is a more interesting question to people that probably have used a little bit of R or a little bit of Pandas, because all of what we've seen can be done in these couple of packages and also in a number of other libraries. The couple main reasons for me are, first of all, that you can use a strongly typed language and experience that it's a number of years doing business applications. Types save your life. And I know this is a controversial discussion, because there are a number of people that prefer dynamically typed languages like JavaScript or Python. But I do think that for business applications, that types give you a hand. So being able to analyze that data, but using a strongly typed language, I think it's a real advantage of using Deedle and things like that. Okay, that's the first thing. It's not something that they don't have, but of course you know that .NET Core also works in Linux. So all I did here, you can do it in a Linux workstation without problem. And of course, F# and Deedle and the type providers are all open source for development, for production, so there are no licensing issues here. Okay. And finally, FSLab. FSLab actually it's an umbrella for a number of frameworks and libraries around data science using F#. I'll just show you Deedle, but just a little bit of Explore. But there's a number of other libraries, most notably statistics libraries and machine learning libraries that you can also use with F#, and they are all under FSLab. Okay. Let me show you a small example of what you can do with FSLab. That definition of here, back here. Okay. There's a template that I particularly like. So probably know you try to create a new application. There's a particular template that's been created by the guys at FSLab, which is the FSLab journal. Let's try and create an FSLab journal. Name FSLab 00, for example. And what this does is it just creates a project that has got Deedle, Explode, statistical libraries, and a number of other stuff there ready to be used. Okay? But so you don't have to worry about what libraries and what reference and stuff like that you should be loading or not loading and versions. It is ready to just start using. But it's even a little bit more interesting because with this guy you can integrate. You'll see many of the examples I show you here, loading files and stuff like that. But you see these interesting comments here. For a chart, these are just comments. That's all here. But sometimes we use 3 stars here. Sometimes we use a couple of stars here. And the reason we use this kind of comments in the Atlas Lab journal is that this has got an HTML generator that let's see it work. What I'm going to do is build build. So what this guy is doing is going to analyze the source code in my FSX file and is going to generate an HTML site. Okay. And actually, it's interesting because all the comments become HTML documentation. And then the code comes nicely formatted. Let's see it right now. This is page. It's not. Let's open it. Give me just a second to show you what was just generated. There you go. Okay. So this here were the comments of my code. This is my actual code. And instead of using just build, you use build run. What will happen is that every time you go changing your source code, by the way, here is the output of the execution of this code. The HTML will be regenerated. So this is very interesting because you can publish the result of your data analysis easily. Finally, you can also incorporate the sharp with Jupyter. Jupyter is a generalization of this idea that actually can use any programming language on a number of programming languages. Python, JavaScript, F#. And so this is my last example here. So you've got my address, you've also got my handle, and if you want to discuss or talk about how to use F# in business and business projects or just massively data, I would love to hear about it. I don't know if you got any other questions.
So the reference inclusions in the FSX files, they had exact
Unfortunately, yes. The only consolation is that actually when you get new versions, your versions are still there. So you will have learning one, but you won't be using the new versions yet. Yes. I'll leave a version in my versions. Thank you very much. And now we're learning